Hi students, this is Alex here. In this video, we are going to verify the Gauss divergence theorem for the given F vector bounded by the region x square plus y square is equal to 4, z is equal to 0 and z is equal to 3. Let's write the Gauss divergence theorem, which is double integral over the surface S F vector dot n cap ds equal to triple integral over the volume del dot F vector dv. Now we are going to construct a small diagram for this given region, which is the cylinder, and the equation is circle and two planes. So let's take a three-dimensional axis. This is x, this is y, this is z, and as usual there is a unit vector I cap along the x-axis, j cap along the y-axis, and k cap along the z-axis. And there is a circle x square plus y square is equal to 4. So we are going to draw that in the xy plane. And the radius is 2 and center is 0. Let's write it here separately. We have x square plus y square equal to 4 is 2 square. And from this, center is 0, 0 and the radius is 2 units. And in the same way, we have another circle which is at z is equal to 3. So by joining these, we get a proper cylinder. And if I take this base region, this is our plane z is equal to 0. This is origin, and this equation is z is equal to 0. And the top region is z is equal to 3. And if we take this point A, this is having a radius 2 units. So 2, 0, 0, because it is on the x-axis. This point is B, which is 2 unit on the y-axis. So 0, 2, 0. Now coming to the left hand side of the Gauss divergence theorem, in LHS we have double integral over S F vector dot n cap ds. So we have three regions. One is the bottom region. So I take it as the bottom plane, which is F vector dot n cap is, for this region, it is pointing downward, which is opposite to that of the k cap. So instead of n cap, I have to take minus k cap, and it is having the dimension x and y. So for ds, it is dx dy plus, in the same way, top region I have to take double integral. This is the top region, and f vector, top region is opposite to that of k, so it is plus k, sorry, opposite to that of the bottom region, which is along the z-axis k cap direction, so dx dy. And here the equation of the plane is z is equal to 0 and this is z is equal to 3. And the third one is a curved surface. We take it as a curved one, f dot n cap ds. Now coming to the first part, I1, we take double integral. F dot minus k cap will be just z square with a minus sign. So minus z square dx dy, and here the equation is 0 for, that is equation of the plane is z is equal to 0. And when I take the limit for x and y, the x limit varies from x is equal to minus 2 till x is equal to 2. But we have an equation x square plus y square is equal to 2 square. So from this, the value of x is root of 2 square minus y square. So here it is minus root of 2 square minus y square, and here it is x is equal to root of 2 square minus y square, the limit of x, and the limit of y, it varies from minus 2 to plus 2. That is, here it is y is equal to minus 2 and here it is y is equal to 2. So using this limit, the limit of x is minus root of 2 square minus y square to root of 2 square minus y square, and this is from minus 2 to 2. Anyway, z is 0, so the total value is 0. Still we have written the limit because it is useful for the calculation of I2. So I2, it is f vector dot k cap, which is only z square without a negative sign, and here the equation of the plane is top surface is z is equal to 3, and we have dx dy, and the limits are same. X varies from minus 2 square minus y square within the root, and this is root of 2 square minus y square, and it is from minus 2 to plus 2. When we substitute z as 3 here, 3 square is 9, so which can be taken outside, double integral, and the limits are same. Now we are going to do the first integration with respect to x alone. So this part we are going to evaluate. Its integration is just x. So it becomes 9 integral minus 2 to 2, and this becomes x, and we use a limit minus 2 root 2 square minus y square root of 2 square minus y square dy. When I substitute the upper limit, then minus of lower limit, it becomes 2 times of root of 2 square minus y square, and we have from minus 2 to 2, outside there is a 9, and we have dy. Now we can take this 2 outside, 9 into 2. Then this is y square, so it is a even function. Suppose if I take f of y as root of 2 square minus y square, then f of minus y is root of 2 square minus y whole square is again positive, but outside there is a negative, so we get the same thing. It means it is an even function. When it is an even function, we have a property when it is from minus a to a f of x dx, it is nothing but 2 times of integral 0 to a f of x dx. So it is easier to apply the limit, use this property. So already we have written this 9 and 2, and by this property one more 2 will come. So into 2 integral 0 to 2 root of 2 square minus y square dy. Now 9 to 18, 18 to 36. We are going to apply the formula, which is y by 2 root of 2 square minus y square plus 2 square by 2 sine inverse y by 2. Limit is from 0 to 2. When we use the upper limit, first part is 0 and second part is, after cancelling this, 2 into sine inverse 2 by 2 sine inverse 1, which is pi by 2. And when I put lower limit, both are 0. So totally it is 36 pi. So here we get 36 pi. Now we have third integration I3, which is the curved surface area. So we take I3 here, which is double integral, and it is curved f vector dot n cap ds. Now we have to calculate what is n cap. N cap is del phi by del phi magnitude. Our equation is x square plus y square is equal to 4. So from this we get phi, which is x square plus y square minus 4. Now del phi is I cap into dou by dou x plus j cap into dou by dou y plus k cap into dou by dou z of this phi, which is x square plus y square minus 4. When we multiply this with the first term, dou by dou x of x square is 2x, and we have I cap, and with the second term it is 2y j cap, and the third term it is 0 because everything is a constant. Now 2 can be taken out, so it is x I cap plus y j cap. So this is our del phi. Now magnitude of del phi is 2 root of x square plus y square, but already we know the value of x square plus y square is 4. So this is 2 root 4. So this is 2 into 2, which is 4. Now finally we got n cap, that is del phi is 2 into xi cap plus y j cap divided by 4. After cancelling this, this is 2. So xi cap plus y j cap by 2. Now we have in the integral f dot n cap. So f we can take from this question. So we copy the f vector here, and with this dot of n cap, which is xi cap plus y j cap by 2. When we do dot product, it is 4x into x by 2, that is corresponding I and I we have to multiply, and j and j we have to multiply, that is minus 2y square into y by 2. So finally this is, after cancelling, we get 2x square, and this is minus y cube. This is our f vector dot n cap. Now we need ds also. ds is either dx dy by n cap dot k cap, or it is dy dz by n cap dot I cap, or it is dz dx by n cap dot j cap. So we have already n cap xi plus yj cap by 2. So using that we can use either the second one or third one, but we cannot use this because we don't have k element. So n cap dot k will become 0. So I'm going to use the second part. So ds equal to dy dz by n cap is xi cap plus y j cap by 2 with this dot product of I cap. So totally this is dy dz by x by 2. So ds is finally 2 by x dy dz. Now coming to the integral f vector dot n cap ds, we have double integral f vector dot n cap is from here 2x square minus y cube. So 2x square minus y cube, the whole thing into 2 by x dy dz. Now we have to replace x. So before that, let's simplify this one. By multiplying this, we get 4x minus 2y cube by x dy dz. But we have equation x square plus y square is equal to 4. From this, x is root of 4 minus y square. So we're going to replace that. So double integral 4 root 4 minus y square minus 2y cube by root 4 minus y square dy dz. Now if we see the limit for y and z from the diagram, we know the limit of z is 0 to 3. So for z we take 0 to 3. But for y, since it is a full circle, we have theta from 0 to 2 pi. So we are going to give substitution y is equal to Since it is a circle, y is equal to r, that is in the parametric form of the circle, x is equal to r cos theta and y is equal to r sin theta, and our equation is x square plus y square is equal to 4, which is 2 square. So 2 square and r value is 2 here. So from this, x is equal to 2 cos theta and y is equal to 2 sin theta. So we are going to give substitution y is equal to 2 sin theta, and we are going to integrate with respect to y first, and the limit of y, it varies from 0 to 2 pi because it's a full circle to cover the full cylinder. So once again we substitute the value integral 0 to 3, and this is integral 4 root 4 minus y square. So 4 minus 2 sin theta whole square, then minus 2y cube. So 2y cube is 2 sin theta whole cube whole divided by root of 4 minus y square is root of 4 minus 2 sin theta whole square. Then at the end we have dy. So from this, dy is 2 cos theta d theta. So here the entire value into 2 cos theta d theta, at the end we have dz. So now when we take the limit for theta, theta varies from 0 to 2 pi. If you see the diagram, we have to complete the full circle, then only we get the full cylinder. So theta varies from 0 to 2 pi. Now we have to simplify this. Integral 0 to 3, integral 0 to 2 pi, 4 root of 4 minus 4 sin square theta, then 2 cube is 8, then into 2, so minus 16 sin cube theta by root of 4 minus 4 sin square theta, the entire value into 2 cos theta d theta, then dz. Now integral 0 to 3, integral 0 to 2 pi, and this is 4. When 4 is taken out, 4 into 1 minus sin square theta is cos square theta, then 16 sin cube theta by root of 4 into cos square theta, the whole thing into 2 cos theta d theta dz. Now integral 0 to 3, integral 0 to 2 pi. This is 4 into 2 cos theta minus 16 sin cube theta by 2 cos theta, the whole thing into 2 cos theta d theta dz. Now we are going to multiply this 2 cos theta with both the terms. So 0 to 3, 0 to 2 pi. This is 8 cos theta and here 2. So 16 cos square theta. Then here it is minus 16 sin cube theta. The whole thing into d theta dz. Here we are going to replace the formula. That is cos square theta is 1 plus cos 2 theta by 2. Then we have sin 3 theta formula, which is 3 sin theta minus 4 sin cube theta. From this 4 sin cube theta is 3 sin theta minus sine 3 theta. So sine cube theta is 3 by 4 sine theta minus 1 by 4 sine 3 theta. So we are going to replace both the formula here. After that we can go for integrating. So substituting this 16 into cos square theta. So we take 16 into 1 plus cos 2 theta whole divided by 2 minus 16. Then we have 3 by 4 sine theta minus 1 by 4 sine 3 theta. Then we have d theta dz and integral 0 to 2 pi, outside 0 to 3. So now we are going to integrate this. This we can cancel. So it is 8 times. So 8 into theta plus sine 2 theta by 2. Then this is minus 16 into 3 by 4, and integration of sine is minus cos theta, then minus 1 by 4, this is minus cos 3 theta by 3 bracket close, and for the entire thing we have the limit from 0 to 2 pi, and outside we have 0 to 3 and dz. So when we apply the limit, this is 8 into 2 pi, and sine 4 pi will become 0, and minus 16 bracket open, this is 3 by 4, cos 2 pi is 1, and already there is a minus sign, and again this will be cos 6 pi, so that is 1 again, and there is a minus 1 by 4, then we have 1, so bracket close. Now coming to the lower limit, minus, and I put 0, the first term is fully 0, then here we have minus 16 into cos 0 is 1, so this is 3 by 4 into minus 1, then again this will become cos 0 is 1 again, so minus 1 by 4 into minus 1, even this part is minus. So after simplifying this, we left with only integral 0 to 3 and dz. So finally this is 16 pi, and when I take this minus 16, and this will become minus 3 by 4 plus 1 by 4. So minus 3 by 4 plus 1 by 4. Then minus of bracket open, again minus 16 into minus 3 by 4 plus 1 by 4. So basically these terms get cancelled. So this minus and this minus will become plus here, and this is a negative term and this is a positive term. Everything gets cancelled. We left with only 16 pi integral 0 to 3 dz. Now simplifying this, 16 pi and integration of dz is z, and limit is from 0 to 3. Totally 16 pi into 3, which is 48 pi. So now total LHS of the Gauss divergence theorem, we have I1 plus I2 plus I3. So I1 is 0, I2 is 36 pi, and this is 48 pi. Totally by adding we get 84 pi. Now coming to the right hand side of the theorem, we have triple integral over the volume and del dot f vector dv. Del dot f vector dv. Now del is I cap into dou by dou x plus j cap into dou by dou y plus k cap into dou by dou z with dot of f, then whole thing dv. and we have triple integral. Now doing the dot product, this will become I dot I when we do 4x, and the derivative with respect to x is only 4. Then j dot j, derivative with respect to y is minus 4y, and this will be 2z. The whole thing into dv is dx dy dz, and we have triple integral. The limit of x is, already we have written, root of 2 minus y square with minus till root of, it is 2 square. 2 square minus y square, and y limit, it varies from minus 2 to 2, and z is varying from 0 to 3. Now coming to the integration part, we are going to do with respect to x. So all these things are constants. So 4 minus 4y plus 2z is fully constant, and derivative of this is x, and we have to use the limit minus 2 square, root of 2 square minus y square to root of 2 square minus y square dy dz, and we have minus 2 to plus 2 with respect to y, and 0 to 3 for with respect to z. Now when we apply the limit, upper limit minus lower limit, it will become 2 times. So 4 minus 4y plus 2z into 2 times of root 2 square minus y square dy. Then we have minus 2 to plus 2 and dz, and outside we have 0 to 3. Now we have to integrate with respect to y. So this 2 into 4 plus 2z alone, I am taking it separately with root of 2 square minus y square, and another term minus 4y into 2, so minus 8y into root of 2 square minus y square. So I split this into 2 parts because I find this as odd function. So this is a odd function. Already in the previous video we have explained what is odd function. When y is replaced as minus y, it becomes, the original function becomes negative times of the, that is f of y. If I take it as 8y root 2 square minus y square, f of minus y becomes minus 8y root of 2 square minus y square. So f of minus y becomes minus f of y. So integral from a to a f of x dx, this property, it becomes 0. So when I integrate, this becomes 0. So it is sufficient if I integrate only this. And here this 2 into 4 plus 2z is a constant, and this integration is y by 2 root of 2 square minus y square plus 2 square by 2 sine inverse y by 2, and our limit is from minus 2 to plus 2, and we have still outside integral 0 to 3. So here 0 to 3, and at the end we have dz. Now 2 into 4 plus 2z, when we apply the limit, first term is 0, second term is 2 square by 2 into pi by 2. When I apply the lower limit, I will get the same thing, so I put into 2 here. So totally we have integral 0 to 3 with respect to z alone. So here we can cancel this 2 and 2 and this and this. So totally 4 pi is a constant, this 2 and this 2 pi. And apart from that, when we integrate this, 4z plus 2z square by 2, and we have to apply the limit 0 to 3. So we can cancel this. Now when we apply the upper limit, it is 12 plus 9, and we have 4 pi. So it is 21 into 4, which is 84. So 84 pi. So we find LHS equal to RHS. So LHS equal to RHS. So from this we can say Gauss divergence theorem is verified.